You push a theme change. Nothing throws an error. The page still renders. But somewhere in there is an assigned variable nobody reads, a hard-coded route that'll break the moment a merchant renames a page, or a translation key that silently falls back to English. Liquid won't stop you, it just renders what you gave it. So what actually catches these mistakes before a real merchant sees them? Today we open the real source behind Shopify ThemeCheck, the linter built into the Shopify CLI, and read exactly how one of its rules is built, end to end. Welcome back to Shopify Development Deep Dive. Part 7 opened the Shopify CLI itself and traced Shopify theme dev from a saved file to a live browser update. Today we open a second CLI command that lives right next to it, Shopify ThemeCheck, and go one level deeper into the actual package that powers it. That package used to be its own repository, simply called themeCheck. It's since been archived, and the real, actively maintained source now lives inside a larger repository called ThemeTools. We're reading the CLI command at tag 4.5.0, and the linter itself at a recent commit on ThemeTools main branch from late June this year. 5 things by the end of this part. Why the original Shopify/theme-check repository is archived, and exactly where its real, still updated source lives today. The real flags behind Shopify ThemeCheck, including a fail-level flag with 6 genuinely distinct severity options, not just error and warning. How the CLI command itself is barely more than a thin wrapper around a published package called at-shopify Shopify/theme-check-node. The real, deliberately ESLint-style shape that every single one of ThemeCheck's rules is built from. And one complete, real check, reads start to finish from its definition, through the code it actually watches for, to the autofix it offers. Here's the whole pipeline in 5 stages. You run Shopify ThemeCheck, which calls themeCheckRun from themeCheck-node. Every liquid in JSON file in your theme gets parsed into a real syntax tree, an AST, not just scanned as text. Then, and this is the key idea, each individual check registers its own visitor a set of functions for exactly the node types it cares about, and only the check's visitor gets called when a matching node shows up anywhere in the tree. When a check's visitor spots a problem, it calls context.report, which records an offense and, for some checks, an automatic fix. And at the end, those offenses either print as text or JSON, or if you pass the auto-correct flag, get applied straight to your files on disk. A short list again. Part 7 of this series is useful background, especially for how the Shopify CLI's commands are structured, since today's check command sits right next to themedev inside that same package. Basic liquid tags and variables from parts 2 and 5 help to specifically assign, capture, and plain variable lookups, since our example check watches for exactly those. Comfort reading a TypeScript function signature is enough. We're reading a real linter today, not writing one. And no prior experience with visitor patterns or abstract syntax trees is required. We build that idea up from the real code itself. This is the real flags object straight out of check.ts, the command file behind Shopify ThemeCheck. The auto-correct flag, short flag A, is what actually lets the linter fix offenses for you instead of just reporting them. But look closely at fail-level. Its real options array has 6 values, not 2, crash, error, suggestion, style, warning, and info. That's a genuinely graded severity system, and the default is error, meaning style and info level offenses won't fail your build unless you explicitly ask them to. List and init rounded out list prints which checks are active, and init generates a starting.theme-check.yml config file. Here's the real answer to where the actual linting logic lives. The check command imports themeCheckRun directly from a published package, @sign Shopify/theme-check-node. Its own runThemeCheck function does almost nothing beyond calling that one imported function and handling the debug message callback. Every flag we just looked at, the path, the config override, the severity level, gets handed straight through. The Shopify CLI doesn't contain a linter. It contains a command that calls one, and that one lives in a separate package we're about to open. This is where themeCheckNode's real logic actually lives. themeCheck common, the package it's built on top of. The real severity enum has 3 numeric levels, error is 0, warning is 1, info is 2. Those are the actual numbers you'll see written into config files in a minute. And every single check in this codebase shares this same meta shape, a unique code, one of those 3 severities, and a docs object with a human description and a link. The comment in this file itself calls this deliberately ESLint-like, and it's not an exaggeration. If you've written an ESLint rule before, this structure will look immediately familiar. Let's follow one real check all the way through in UnusedAssign, the rule that flags a liquid variable you assigned but never actually used anywhere. This is its real meta object. The code is the literal string in UnusedAssign, the same string you'd see in a .theme-check.yml file to configure it. Its description is the real sentence from the source. It exists to prevent bloat in themes by surfacing variable definitions that are not used. It's marked recommended true, meaning it ships active by default, at severity warning not an error, since an unused variable doesn't break your storefront, it just quietly wastes bytes. This is the real visitor pattern in action, the same idea the types file promised. UnusedAssign's create function returns an object whose keys are literal AST node type names. Liquid tag fires every time the parser hits any liquid tag anywhere in the file, and this check only cares about the assign ones, recording each variable name into a map. Variable lookup fires every time any variable gets read anywhere in an output tag, inside an if condition, anywhere and every one of those gets added to a set. Two tiny functions, and themeCheck's engine handles all the actual tree walking underneath them. Once the whole file's been walked, onCodePathEnd runs once, comparing the two collections. Any variable that was assigned but never shows up in used variables gets reported with the real message string, an exact start and end position in the file, and, notice this, a suggest array with an actual fix function. That fix doesn't just describe the problem, it calls a corrector's remove method with the exact same start and end position. That's the real code your editor calls when you accept themeCheck's quick fix, or when the auto-correct flag from step 1 runs unattended. And this is real, literal content from recommended.yml. The config file behind theme-check:recommended, the default most themes actually run. Its own header warns it's generated automatically by a script and should never be hand-edited. And there's UnusedAssign again, enabled true, Severity 1 exactly the numeric warning value from the Severity enum we read in step 3, not a guess, not a paraphrase, the literal number written into this file. Dozens of other checks, like deprecated tag right below it, follow the exact same two-line shape. Stated as one real chain, start to finish. You run Shopify ThemeCheck with fail-level set to warning. The command hands everything straight to themeCheckRun in theme-check-node. Every checks visitor in UnusedAssign among dozens of others walks the parsed AST looking for its own node types. Once a file's fully walked, onCodePathEnd compares what got assigned against what got used, and calls context.report on anything left over. And because you asked for fail-level warning instead of the default error, that offense doesn't just print, it fails the command outright. A few things worth being precise about. If you go looking for ThemeCheck source and land on Shopify/theme-check, that repository is archived. The real, actively updated code is one directory inside Shopify/theme-tools. The fail-level flag has 6 real options, and its default is error, so warning and style level offenses like an unused variable won't fail your build unless you deliberately raise the threshold. Recommended.yml is auto-generated by a script hand-editing, it doesn't stick. Your .theme-check.yml file is the actual place to override settings. And not every check offers an autofix. The suggest array on context.report is entirely optional, and UnusedAssign happens to use it, but plenty of checks only report, they never propose a fix. Pulling it together. ThemeCheck's Rail source moved out of the now archived ThemeCheck repository and into themetools, where it's actively maintained today. Shopify ThemeCheck itself is barely more than a thin wrapper around themeChecknode's themeCheckRun function. The CLI doesn't lint anything itself. Every one of its checks shares one real, deliberately ESLint-style shape, a meta-object describing the rule, and a visitor returned from create context that only sees the node types it registered for. And UnusedAssign is one complete example, tracking assigned against used variables, then reporting with a genuine autofix. And recommended.yml is the real, auto-generated config file that turns dozens of checks like it on by default, the moment you run Shopify ThemeCheck on a real theme. That's the real path from a saved theme file to a reported offense in one complete real check, read from its meta-object to its autofix. Part 9 leaves themes behind for a while and opens Shopify functions, and the real reason Shopify replaced the old scripts platform with a Rust-based system instead. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 9.